Okay, so for this one we're after an empirical formula of a compound containing this percentage of carbon and this percentage of hydrogen. And what we're going to do here is we're going to assume we have 100 grams of compound, which means that we'd have 85.7 grams of carbon and 14.3 grams of hydrogen if we assume we had 100 grams of compound. First of all, we'll get the moles of carbon, and that's going to be 85.7 grams of carbon, and then we will grams of carbon on the bottom. We'll have moles of carbon on top. 1 mole of carbon is equal to 12.01 grams of carbon. We're going to come out with that to be 7.14 moles of C. Do the same thing with the hydrogen. And it's going to be 14.3 grams of hydrogen. Put grams of hydrogen on the bottom. Moles of hydrogen on top. The relationship here, 1 mole of hydrogen is equal to 1.01 grams of hydrogen, and that's going to be 14.2 moles of hydrogen. And the next thing we want to do is take these and divide them by the smallest number of moles, which is going to be the carbon moles there. So 7.14 divided by 7.14 moles for each of those carbons. That's going to be 1, and that's for the carbon. And then we'll do the same thing for the hydrogen. 14.2 moles of hydrogen divided by 7.14 moles for the carbon, and that's going to be 1.98. And that's going to be rounded to 2, so that's going to be for the hydrogen. So the multiplier here will be 1 and 1, since we're just rounding to whole numbers, and our final moles here, or mole ratio, will be C is to H, will be 1 is to 2, so that's how we end up getting our formula of CH2.